Let x and y be continuous random variables with a joint distribution function f of xy, and let f sub x be the PDF of x. Then the conditional distribution of y given a value of x is f of y given x of, we write the input as little y given little x, is equal to f of xy over f of x. So this is pretty similar to conditional probability. Whenever we're given an event B, so the probability of A given B, we write it as P A bar B. And for the conditional distribution, we have f of y bar x is equal to, and then for the definition for events, we have the probability of A and B, or the probability of A intersect B on top, and then the probability of B on bottom, where B is the thing we're given. So similarly here, we have the f of xy on top, which is like x equals x and y equals y, and then we're dividing by the thing that we're given, because we're given x, so we divide by f sub x of x, or the PDF of x at x. So let's do an example. We're going to take random variables x and y with the joint PDF f of xy equals 3x for 0 less than or equal to x less than or equal to 1, and 0 less than or equal to y less than or equal to 1, and for y less than x. So right now we're looking at from 0 to 1 on both x and y, and then this would be the line y equals x, and so this region over here is where y is less than x. It's inside this triangle. So over this region, we have f of xy is equal to just 3x. What is the probability y is greater than 0.1 if x equals 0.25? So somehow we get a value x equals 0.25, and we want to know the probability that y is less than 0.1. So first we can find the conditional distribution of y given x equals 0.25. But we need to find the PDF of x first, which we can do by integrating f of xy over y. So the PDF of x is the integral from 0 to x of 3x dy, since y is going to be between 0 and x. So this is just y from 0 to x, or 3x squared. Now by definition, f of y given x has a conditional probability density function of f of xy, which is 3x, divided by f of x, which we just found to be 3x squared, or 1 over x. So given that x equals 0.25, y, since it's between 0 and x, must be between 0 and 0.25, and f of y given x is 1 over 0.25, or 4. So the PDF of y given x equals 0.25 is 4, from 0 to 0.25. And so the probability y is greater than 1 is the integral from 0.1 to 0.25, since y is bounded by 0.25, of 4 dy, which equals 0.6. So there's a 0.6 chance that y is going to be greater than 0.1 given x equals 0.25. And by rearranging the formula, just as we did with conditional events, we get a multiplication rule. So the joint PDF f of xy is equal to f of y given x of y given x f times the PDF of x. So suppose x has PDF f of x equals 1 for x between 0 and 1. If you're familiar with it, it's a uniform random variable on 0, 1. And given that x equals the value little x, y has PDF x e to the minus xy for y bigger than 0. If you're familiar with the exponential distribution, that just means it's exponential with parameter x. So what's the probability that x and y land in 1/2 1 to 1/2 1? And if we were to graph this, so y could be anything bigger than or equal to 0. So this has positive probability going from 1 on the x-axis, because x only goes from 0 to 1, but y goes up to infinity. So x and y land somewhere in this strip. And we want to know the probability that x and y land inside this box, that they're both between 1/2 and 1. So we want to integrate f of xy, the joint PDF, over that region. So the region from 1/2 to 1 dy and from 1/2 to 1 dx of f of xy. To find f of xy, we can use the product rule. So f of xy equals f of y given x times f of x, where f of x is 1 from x between 0 and 1, and f of y given x is x e to the minus xy for y bigger than 0. And so therefore, f of xy is x e to the minus xy for x between 0 and 1 and y bigger than 0. The product here is easy to compute because it's just 1 times x e to the minus xy, but make sure you're careful with these bounds. So the bounds are, only applies if x is between 0 and 1 and y is bigger than 0. So now, we're going to compute the probability that xy is in 1/2 1 by 1/2 1, so the square 1/2 1 cross 1/2 1. And so this is the double integral from 1/2 to 1 of f of xy dx dy, which is x e to the minus xy. And then evaluating this integral with respect to y first, the x's cancel, and we evaluate from 1 to 1/2, so we get e to the x negative x over 2 minus e to the negative x. And then we evaluate that with respect to x. So negative 2 e to the minus x over 2 plus e to the minus x from x equals 1/2 to 1. And that's 2 e to the minus a fourth plus e to the minus 1 minus e to the minus 1/2. So this is all just standard integration. I don't even think there's a substitution or integration by parts here. Just by integrating the exponents twice, we get that the probability is roughly 0.106.